Thank you, Kai. So, I hope I can manage all these techniques here with the microphone, and I wanted to go back. Didn't want to start with a slide. First of all, good morning, dear colleagues, ladies and gentlemen, dear friends. And for me, it's a hard job. This is how I estimate it. You know, FREI OTTO has worked more than 70 years in the field. And I only have 30 minutes. What can I tell you about 70 years of life work in 30 minutes? And so I had the problem to select it, to make a selection as dense as possible, and this is what I did. So don't expect, it's not a scientific lecture, it's just a bunch of pictures and remarks on it, of the main fields and the main objects and the main goals FREI OTTO had during his life of work. So his first breakthrough in the international world of architects and engineers was the German Pavilion 1987 on the Expo in Montreal in Canada. And it was the first pre-stressed cable net ever built. That's what we thought. The first one was 20 years before, already built by Australian engineers and architects in Melbourne, the so-called Myers Music Hall. We thought it's the first one, and the world of architects and engineers are thinking the same. The big thing after Montreal was Munich. Montreal was 10,000 square meters. Munich was the Olympic roofs. If I say Munich, I mean the Olympic roofs in 1972 in Munich. Munich had a size or covered area of more than 70,000 square meters, 7 times bigger than the Montreal was. And FREI OTTO was afraid of doing it. At first, he didn't want to do that. But he was convinced, he convinced himself to do this job together with Günther Benisch, that was the architect and his group, and together with the engineers around Fritz Leonhardt, and at least the main chief engineer on site was Jörg Schlabich. In all these years, before Munich, before Montreal, FREI OTTO did a lot of tents. And nobody took care of it. There was a very small group of people watching that exciting things. They are repeated more and more in the world. You can find the dancing fountain of the Federal Garden exhibition in Cologne, which was in '57, long before Montreal. You can find repetitions or plagiatism of that all over the world. But the best was this one. And also this was for the Federal Garden exhibition in Cologne. Just an arch, a banded tube, 30 centimeters in diameter, supporting a membrane, without any connection between arch and membrane. And that was the place where FREI was working. His first little atelier in Berlin, what he called, it was a private development institution or institute in the garden of the parents of his wife. Just a little hut made of glass and wood. FREI OTTO was born in 1925, and he wanted to study architecture from the first beginning. But the Second World War prohibited that he could start immediately. He first has to go to the army, and he was a pilot, a combat pilot in the German Air Force for 2 years, from 43 to 45. First after the war, he could start his studies, and then he continued rapidly. Up to 52, I think, he got his degree, and he prepared his doctor thesis, which is still on the market, in the book market. It's the suspended roof, that's the title. And he founded this little office here. And from that beginning, he started to build tents, small ones, primitive ones, high ponds, and even this little fountain there was one of his work. And then he met Peter Strohmeyer, the head of the Strohmeyer company, one of the biggest, at this time, the biggest tent building company in Europe. And they became friends. And together with Peter Strohmeyer, he built these tents for Federal Garden exhibitions, for, on the left side, Federal Swiss country exhibition, and things like that. Or he developed already. He started to develop high points, low points, points where, oh, that was wrong. Here we are. I want to show this point here. Low points inside a membrane. One of the best solutions you can find, and repeat it in a very primitive way very often, unfortunately. And that's the same with the high points. But look at that. That's also for a Federal Garden exhibition in Hamburg. That was, I just mentioned some dates that you get a kind of chronology in the whole thing. It was 63 already, still before Montreal, and nobody really took care of it. Nobody noticed it I would say, in the right way, how beautiful this architecture was. Look at this way of using a pattern, not only just to make a membrane in space, but as an ornament, to use this structural necessity of a pattern to describe shapes in space. But also, FREI worked with other structures. Look at the left side. This is a little footbridge with on cables, just with a slender plate of concrete or steel it's for pedestrian only. And he developed houses in spatial nets, put in computers in which not computers, containers in which people can live. Just add one container to the next one in a spatial net, pre-stressed cable net structure. Or the idea to create a shape which is covered with a membrane with several planes inside or levels inside on which you can build a park, you can build houses here. And the basic idea came out for a proposal for a world exhibition in Osaka. That was a design for the pavilion of India, not executed. But the idea which was developed here, you see the levels here inside, came from this little sketch. And another idea was an ecological idea to cover a whole university just with one surface of a membrane. And that was made for the Medical Academy in Ulm, in a German town close to Munich or between Munich and Stuttgart. And it had an extremely ecological approach. This should be a convertible roof, which was able to collect energy from the sun. It could turn around following the sun. An idea in these times was completely new. But people didn't realize what's the potential behind these ideas. And he also worked with that's a so-called Vierendeel beam, as it's a clock tower of a church. And this is a crane following the vertebrae of human beings. It's a movable crane. This top here can move in the space, using the system in which our human vertebrae is built, just in a technical object. Another basic idea of FREI OTTO was to work, to look into nature, find out principles, find out processes which are forming structures and objects in living and non-living nature. A design on the left side for the Olympic Stadium in Berlin, and another one, a preliminary study of high and low points directed to Montreal, the pavilion in Montreal, to have high and low points to distribute it over a surface, to carry forces from a membrane down to the ground. That was Montreal. And you see the high point here, exactly the same you have seen before, and the low point here. And Montreal was full of these structural details or formal details, morphological details. And underneath of the Montreal Pavilion, there was another test structure. What was a grid shell made of wooden rods, the first wooden grid shell built in this way, produced in Germany, transported to Montreal, and put underneath the pavilion. The pavilion was a pre-stressed cable net with a membrane suspended, covering the space, suspended from the net. This is FREI OTTO walking on the net. That was the only reason for the 50-centimeter mesh. You could walk on it. It could be a mesh of 1 meter or any distance, doesn't matter. It will be the same structure of a pre-stressed cable net. But 50 centimeters made it safe to work on it, to walk on it. You cannot fall through. Just make like that, and you will be stopped immediately. And that was the end of Montreal over there. A mast was broken by, it wasn't watertight. There was water in the mast. The water was freezing, and the mast was destroyed and fell down in the net and destroyed a big area inside the net. And the Canadian didn't want to repair it. They sold it for one symbolic Canadian dollar to a company wrecking it down. The Institute building, the test building for the Montreal Pavilion, with all the details are exactly Montreal. For instance, the problem of a tent structure is under load there are big deflections. And we wanted to build, I say we, because at this time I already was a member of the group working with FREI and tried, even in this preliminary test building here, experimental building for Montreal, I already was working with him. We loaded with sandbags to push it down artificially. We fixed steel rods to the strip foundation in the ground, and then we get out. We had a pre-stressed facade, simply done just by pushing it down by load. And it worked perfectly. There was no breakage all the years. That was one of the main points FREI worked with. Soap films, developing shapes, finding a form on a physical and a chemical, and maybe in nature on a genetic basis, but governed by rules from nature, physical, chemical rules, and biological rules, and not just arbitrarily found and by the intention of a designer who wanted to do it like that. There was always a basis because the forms came by themselves, also with the soap bubbles. And the model methods developed in these times, liquid plaster blowing up rubber membranes, still used. Even if you have these fine fluid structure interaction programs, they don't describe much more than just that. Or rigid structures, bone structures, transported or transformed to applications in architecture, not only rods, but also membranes here. Also, this is a model. The model was the basis of everything FREI OTTO did. We also worked, or he worked also with us in the Institute on things which are far away of so high technology, lightweight structures. We made some studies about houses using these houses in Sumatra, a native house. And the particular point is this tension-stressed bridge on top, made of bamboo. And the whole thing is supported by this A-frame, also made of bamboo, on both sides. It's a perfect equilibrium because between these two systems, rods on the rods along the roof surface are under, to a certain extent, under compression, but they are also under tension. And the same, we worked a lot on Shukhov, Vladimir Shukhov, an engineer, a Russian engineer, who built beautiful structures just by hand. He didn't have any computer methods to calculate this radio tower close to or in the area of Moscow. It's 150 meters high. And it was in a time in which 1922, just filigrane steel work. And he calculated in standing upright, still standing upright. Oh, this is what you should have a look to on Sagrada Familia, in the crypta of Sagrada Familia. This is a model of the Colonia Güell. This is one of Gaudi's buildings, which was not finished, only started with the foundations and with the first level. And we built it completely following photos. And this model could be, it's a suspended model. This model you can see in the crypta of the Sagrada Familia, if you are prepared to join the queue waiting for the entrance. That's Munich again. And this is to show you, this is a model and nothing more. And this model shows us that it is possible to create these 400-meter long edge cable for the stadium roof. We loaded it simply with the maximum snow loads by this little weights here, and we watched the deflection. And we found out it's not deflected as it was calculated before by hand. There have been no programs to calculate it. There was a method by Rudolf Trostel just to do it on a mathematical basis by hand. And he found out, or he verified our experiments in the model. And then the decision was made, let's build Munich in the way in which Günter Benich and FREI OTTO have suggested it. We did 25 or maybe 30 models to find out the structural system for getting the span of the grandstand of the stadium. And in this time, and in one of these models, we invented the flying mast, which you can find now if you have a visit to do a visit to the Olympics in Munich. This flying mast was the only possibility to cover a span of close to 40 meters, free span to the edge cable and to the mast at the backside of the stand. It was necessary to push up the membrane or the net in one intermediate point, and this was made by this flying mast. That was the complicated erection method, and that's how it looks like now. was in 1972. And another field for FREI OTTO have been the convertible roofs. Movable membranes, if it's raining, spread them out. If you have a nice weather, bench them on the top of a mast. And again, it was an experiment. Look at this mast here. It has a parabolic curvature, and to stabilize it, it's just a thin tube of 30 centimeters, about that, steel tube, and it has a kind of a hull going backwards to avoid buckling, because it's pre-buckled in this curvature. That trick you must find out. It has to do with thinking about how structures are taking loads and how they are acting with loads. Or the Hersfeld Theater, also convertible, on an old ruin to cover the space. To cover the space for the audience. That was in '67, and this one was the first. On the left side was the first one he did with the first convertible roof in this modern technical way, together with Talibert, a French architect. And Talibert also has tried to build something like this on the left side, a huge convertible roof for the Olympic Stadium in Montreal, for the Olympics in Montreal. And they were in, I don't know, I made a note here. It's important to know this, but I don't find it right now. I'm sorry. It was long after the pavilion was built, Montreal Olympics. Well, I'm sorry, I don't find it. Too many dates. But they failed. Talibert failed insofar that this convertible roof was moved only 2 or 3 times. And then they stopped it and never moved it again. And they asked Jörg Schleich to, I'm going to tell stories. The Pink Floyd umbrellas at the other side, another convertible roof system. 3 structures, an invention of, it's not an invention, but FREI tried to understand the way of how they carry forces and use it for architectural, structural reasons, to take compression loads, exterior loads, used for plain roofs, used for the transrapid rail, which is not allowed to move less than or more than 2 millimeters when the train is driving, and the suspended structures, grid shells, found with models, suspended hanging nets, and built. The first one in Berkeley on the left side was built of reinforced rods, just 2 in each knot. And the right one is made of wood. And the biggest one was the Menan shell on the right side, 7,000 square meters covered area. This is how it looks inside. A wooden grid, 50 centimeters again, to the same reason as we did it for the Montreal Pavilion. And again, an edge with cables for compression, bending stress structure, for a shell structure. The load is taken by this cable here. And another cable is inside the grid to take suction forces. Simple and basic, but never done before and never used afterwards. And this is how it looks like on the left, on the right side. Or the aviary in Munich, using mesh grid material to build a pre-stressed cable net, not wire net structure, 60 centimeters mesh width. Just normally used for fences and things like that. Another tricky thing, it's an ice skating rink in Wales, designed for that, which is half a heavyweight structure. It's loaded or stabilized by the snow laying on it. And it has only very small pre-stress against wind. And it is allowed to move on the wind, to swing. But if the snow comes, the heavy load, the dangerous load, it's stabilized by the load. That's another way of thinking about how structures are acting under load. And his utopistic ideas. Swimming islands, pneumatic islands, high-rising buildings, or a dam with a pneumatic membrane where the high loads are carried by a cable net. And that's again what he was driven by. Working about structures, generating processes in nature, in living nature and in non-living nature. And to describe the bases which are always based on natural laws, chemical, physical, genetic, and the combination of them. And another nice thing, that's a sports hall in Saudi Arabia of the King Abdulaziz University with natural cooling. You know, the Arabs build houses where the wind flow, the change of temperature on the ground and in a certain height creates a kind of a draft inside the building. And the same system used here. It's a cable net, that is the load-carrying structure. There's an interior membrane and an exterior membrane and this big space between. And up here are the outlets. And it works without, nearly without additional energy or cooling devices. Using old techniques which are in use since, I don't know, centuries, decades. Another Saudi Arabian project, the diplomatic club with a little glass-covered fountain roof, which Browder's daughter has painted. It's painted glass. In this book, and that's why I show it, are more than 400 questions formulated and worked out and described, which are not solved. And they are covering the whole field of science, from medicine to pure physics and chemistry to engineering and architecture. More than 400 subjects on which it would be worthwhile to work on, to do research on it. The main problems are not solved. Do not think about that. That was what FREI was always preaching. We are still on a good way, but we haven't found the final solutions. And let us look for those solutions. And we had a lot of, these are just some interior pictures now of the Institute. We had a lot of friends. He had a lot of friends. The whole range of important persons, architects and engineers in his times, in these years between 64, where the Institute was founded, up to 91, where he was retired. There was Kenzo Tange, his Olympic roofs you see here in Tokyo. There was Buckminster Fuller. And they are playing with a little tensegrity model, which what Buckminster has built in a 5-hour lecture at Stuttgart University. And there was Felix Candela with his famous and incredible thin concrete shells. And there was a big exchange of ideas or hard discussions among FREI and his group and all these famous people. And this is the other one here. This one is Walter Bird, who was the pioneer of pneumatic structures in the United States before the Second World War, during the war and after the war. He had his own company, Bird Air Structures. Or again, Peter Strohmeyer, a circus tent builder, a genius of building chapiteaux. That's the main circus tent. Its name is chapiteau. And he was the big mentor of FREI OTTO. Without Peter Strohmeyer's help, FREI OTTO would never have been able to build the tents you have seen before. Or Heinz Isler, the Swiss engineer, building beautiful shells, concrete shells, but based on experiment. He had a certain trick. To describe that, it takes much more time. But he built, look at this beautiful, it's a gas station. What a beautiful shell, natural shell, based on on an experimental basis, calculated simply afterwards. Johann Gerhard Helmke, the head of the Max Planck Institute at the University in Berlin. I have to finish. Bringing FREI OTTO in contact to all these tiny little living beings, radiolaria, diatoms, and so on, to investigate their structural system and the processes, how they come to life, how they work. Rolf Gutbrod, the one with whom he built the Montreal Pavilion. Fritz Leonhardt, who brought him to Stuttgart University, and the inventor and the concrete man who built the first concrete TV tower in Stuttgart. He was the rector of the university at this time, and he took FREI OTTO, brought him to Stuttgart, made an institute for him, the Institute for Lightweight Structures. He observed, he felt, and he had the idea that this guy, FREI OTTO, could really do something what was never done before. And we had a lot of meetings at the Institute, one symposium after the other, sometimes 4 or 5 a year. And it was full of people, with those which I have shown, and a whole crowd of, let me say, scholars following FREI's ideas. And always we had a dancing after this farewell party, and FREI OTTO did the first dance with his wife to open the dancing in this party. The nature was one field for him, the generating processes in nature, and the other one was the mankind, human beings, how they live. This is the group of people for which we do all this architecture, you know. For whom else are you doing buildings? For people, for living beings. And that was the driving point for FREI OTTO. So, the king is dead now. And I would say he died at the beginning of March, 2 weeks before his 90th birthday. He was nearly 90 years old. The king is dead now. God save the king. Le roi est mort. This is what the French say. And how do they continue? Le roi est mort, vive le roi. And finally, der König ist tot in German. Es lebe der König. Thank you very much.